All right. How is it going? How is it going this fine day? This fine day, peoples? What's good? What is good today? What is good? That is my way of saying hello. What's up? You guys doing good? I hope so. Well, you guys doing well? Turn it up. I definitely hope you are. Much love if you are. Yeah. Happy Monday? Sure. We're here. Let's go. Lurkers and twerkers, sandwich making workers. Thank you for stopping by. Let's go. You peoples, you awesome, beautiful, intelligent peoples. Turn it up. Appreciate you. Followers, supporters of the channels, Twitch, you guys are killing it. I love it. I love you peoples over here in Twitch land. Sorry, YouTube. I gave you guys a chance. You didn't step up. But, yeah, Twitch, you guys. Thank you for the views, guys and gals. Whoever you are, you guys are killing it. Killing it. And I love it. I love it. So many views. So many views. supports and follows. You guys, man, it's so great to be over here. Every single one of you make me feel good. Make me feel good, knowing that I'm not just doing this for nothing and talking to myself. Let's go. Awesome sauce. All right, I want to quickly throw it out there for you guys, recent followers, Wicked Stat, iDucky, Kamikaze, Don to the One. Thank you for the raids. Man, you're awesome, bro. Amir Hassan, 23, Kenny M. Gassy, A Music, Chama _117, and recent follow, Rough Riders Gaming. Let's go! Let's go. Rough Riders Gaming, I appreciate you. I did I did drop by your channel. I did. And I tried to hit you with a follow. And yeah, well, you got it set on verified. I understand the reasoning behind it. Yeah, I don't blame ya. I wanted to follow you, bro, but I couldn't. Me's don't have a cell phone. No cell phone for me. Does everybody think I'm rich or something? Man, how many times have I been telling you guys I'm living off bologna and wiener sandwiches? You think you would get it from that? I can't afford a phone. Crazy thoughts, man. Crazy thoughts. All right. Yeah. Man, yeah. I think I had some good sleep last night. It is Monday, so I'm going to do my best with another class/lecture today. It is Monday, like I said. Tomorrow, guys, there won't be a stream because, yeah, I'm just going to keep the vibes positive, but I'm just going to say my uncle. That's it. That's all I'm going to say. So, yeah, busy tomorrow. Yeah. Anyways, gotta regain my thoughts here. Stay on track. Followers, supporters, those of you that are viewing and watching the content, you guys are great. You're absolutely fabuloso. Fabuloso. You are solid people. I care about you. I do. Let's go. I guess I should get to it. Those of you that are just dropping by for the first time, it's great to have you. Truly is. It's so great to have you. Really is. Yeah, a lot of you guys, man. Whew. Even you guys popping in on the stream and stuff, like my OBS, my Streamlabs doesn't tell me anything. It doesn't even update. It says 1 all the time. So I always assume there's only 1. I don't know what's up. It's Streamlabs, it's PC application I installed. Anyways, it doesn't update. But I don't have a stream up, so I don't know. But yeah, I do get the emails from Twitch. Twitch is great for that. Yes, they are. So they let me know, and I'm like, whoa, look at those numbers. Wow, where you guys come from? Anyways, doesn't matter. It's great to have you. Keep it up, guys. Keep it up. Thank you. I know I go on and on and on, but I just want you to know I'm being clear here. Being clear so you fully understand where I'm coming from. So yeah, if you're just dropping by for the first time, guys and gals, I recommend, like, if you want to learn C++ coding, that's great. I support you in your dream and endeavor of learning C++. Yeah. Here to support, here to help. I'm going to do my best to instruct and teach with examples, by example, explain without hopefully not over-explaining. That's kind of the goal. I've been working on that. This is a class/lecture, so if you want to learn, I recommend you start from the beginning of the series. I export all my live streams to YouTube, so every live stream is there on the channel. Okay, guys, if you want to check it out and you want to follow along, it's there. WhiskeyTango Sharp Coding. WhiskeyTango Sharp. I am Johnny. Thank you for being here. Thank you for being here. So yeah, it's great to have you. You can watch the stream, stick around, and yeah. Let's get to it. I think we should get right to it, guys and gals. Yeah. You ready to learn? Ready? Are you ready to learn? Let's do some learnings. Let's go over to ye school over yonder. One quick thing, and then we're going to get going. A couple of quick mod things to get out of the way. But in the meantime, I will do this for you guys and gals. You awesome people. Yeah, let's go. That's right. That's for every single one of you lurkers, twerkers, viewers, supporters, followers of the channel. You guys are awesome. Throwing it out there for you. We're going to get going here. I want to just finish up with a couple of final things here in chat, mod stuff. Check the stream. Make sure we're good. Make sure we're golden. Golden like the Golden Girls. Yeah. I don't know what it is. I just like saying that. It's fun. It's fun for me. Hopefully you get a laugh. Because that's kind of the goal. Too many things going up here. Let's go. Almost done. Get this finished. Don't forget to buy me a coffee, because Johnny with coffee is a happy Johnny. I'm telling you, that's facts. I think I've gotten the quotes for the day done, I believe. This is a good one. Did I, there was one that I really like. Yeah, here it is. Let's do this one. And we'll finish up, guys. Trying to hurry here. I am my own mod, so please bear with me. I am unable to clone ye self. No cloning machine over here. One more thing. And then I can get rid of this document. So I have last tabbed up. Okay, that's done. Check the stream quickly. Make sure we're good. I'm sure we are, but I gotta make sure. I can get rid of this document. Perfect. Awesome. Sawsome. I love it. Okay, guys and gals, it is time. It is time. Time to throw on the old Yee thinking cap. Let's do some learning, because learning is fun. All right? You're filling up that library up in the head is what you're doing. It doesn't have to be coding, but at least fill it with something. Sheesh! Because why not? All right, hopefully the music isn't too loud. Maybe it's just right. I don't know. Hopefully we're good. Okay, all right, we're getting towards the end of thinking cap, boys and girls. Put on your thinking cap, flick the old switch in the cranium brainium, and it's time to learn. Finishing up here, we're going to be doing some more OOP, object-oriented programming, but we're kind of getting to the end of understanding OOP. Okay, there will be more. We will be doing further object-oriented programming because it's fun. Objects make the magic happen. I was going to go over some... Yeah, let's do that. They have some... Again, I'm following a course outline here, guys and gals. It's a bit of an older one, but the theory and everything's all the same for the most part. Some of the coding has changed over time, the way coding is done. Classes have obviously been around for a long time, 20 plus years. Kind of moved from doing structs. Structs is kind of the foundation for classes, really. From C to C++, classes could do a little bit more. Structure's still great. You can use them for like just basic variables, maybe X, Y type stuff. I'm going to do a class today as an example. They have one here, classes with other members as member data. It's a little lengthy, and it's kind of just the way it's set up. It's not set up the way I'm showing you guys how to write code, how to break your classes into parts. So, and I don't know, I tried running it, and anyways, just going to leave it at that. So I'm going to do my own version of it, so you will get something. But I figured maybe I'll begin with kind of just talking about data types and primitive data types. We haven't really gone over a lot of the finer details, maybe a little bit. Some I've kind of touched base on. We'll just kind of give it a little bit more of a definition for you guys and gals. That's kind of, in essence what I'm doing. A further definition, right? So I have this, I've shared this a bunch of times. You might find this on the old interwebs somewhere. Search, I don't know, data types, search data types, min and max values, or data types memory, C++, something to that effect. Sure, you'll find something you could screenshot. There is a lot of good stuff on the internet. You can get good support information, but you just got to be careful, right? I recommend kind of getting a better understanding of the code and writing code and, just grinding out statements and practicing different programs, or eventually try your own little programs, do different things. And as you progress and get better, you'll have a better understanding what's happening, because, you get to see it, right, when you're actually doing it. And then you could go to the internet if you need any extra support. Maybe you're stuck somewhere on something. And the more you do, the better you're going to get. You're going to become more knowledgeable, and you'll be able to kind of look at the stuff on the internet and go, yeah, no, pass. Which way do you swipe, guys? Is it swipe left, swipe right? I don't know. I'm not a swiper, because swipers stop swiping. I don't know. That was just random, guys. It was just random. Random thoughts. So yeah, you'll be able to go, yeah, that person doesn't know what they're doing. And then you'll see there is good stuff out there. A lot of good support information. I know it's a new world of AI. Literally, like, I don't want to go down that road, but it's like, it's going to be to the point where people are going to be literally useless. Literally useless. They won't even be able to think for themselves anymore. They'll literally be slowly becoming NPCs. My prediction, 20, 30 years, people are all going to be NPCs. Just kidding. Just jokes, guys. Why so serious, Bob? So these are my thoughts, right? With this AI stuff and ChatGPT, and you're pretty much given the trophy. You're pretty much given the answers. So, like, really, are you learning? Are you really learning anything by being given the answers? Boss, can you give me? The boss gives you an assignment, and you go, boss, can you give me all the work? Boss, I got it done. Like, what the? I don't know. I could be wrong, but really. Anyways, this AI stuff, you know. You gotta think for yourself, man. Guys, gals, you gotta be thinkers. Be thinkers. Alright? You gotta grind your own code. I recommend you grind your code. Practice yourself. Right? And you're gonna hit barriers. You're gonna hit walls. It's gonna happen. You're not the only one in the world it ever happened to. So if you really get stuck, then you can just kind of, okay, I tried, right? Kind of attitude. And you could give yourself a pat on the back because you actually tried, right? At least you tried. You made the effort. And you're like winner, chicken dinner, doing already better than that person that has all the answers handed to them, you know? Because you're not learning from just it being given to you. Like, really. Anyways, I'm going to stop on that because, yeah, I have real thoughts about that, but, yeah. So, we're going to move forward. Positive, guys. Positive. I believe in every single one of you. Put in the effort. Try it yourself. And then it's okay to go to the internet or wherever you want to do your searches, okay? That's what I recommend. Okay. Hopefully that helps. Hey, it's great to have you. Thank you for stopping by, lurker and twerker. Sandwich making workers. Turn it off. You're awesome. Just stopping by. Let's go. You guys. I love it. All right, we're going to get into talking about primitive data types a little bit. I'm not going to go too extensive into it. It's just kind of a little bit of review, more of a definition, a little more theory about the different data types. Hopefully I won't be doing this for too long, and then we're going to grind up some code. We're going to do a new class. We're going to get rid of this cat manager. It was a pretty good example. I want to finish off this series, this OOP series. I mean, this is kind of the section on understanding. We're just kind of getting into it, right? And then I want to move on to the next section, okay? It's great to have you, every single one of you. Coffee time, and then I'm going to do some reading. Hopefully you don't mind me torturing you with some reading. Let's go. Oh, yeah. All right. There we go. Okay. Primitive data types. We're doing this, guys. Where do I begin? Let's see. In C++, primitive data types are fundamental. Okay, so I'll just kind of bring this up just so you have a visual at least right here. Yeah. Okay. You know, we're going to talk about some of them, right? So you have an idea. Built-in data types that are directly supported by the language and the underlying hardware. These types form the basic building blocks for storing and manipulating data within a C++ program. Key characteristics. Excuse me, guys. Key characteristics of primitive data types in C++. Built-in. Okay? Built-in, like I'll talk about, I'll maybe refer to methods as built-in. They're basically methods that are kind of just created for us by the fine devs, you know, in the background. When you bring in, let's say, a string class, for example, the string class itself has its own built-in methods. So that's what the word or term built-in means. Okay? It's provided for us. They are inherent part of the C++ language specification, not defined by the user. Represent fundamental data. They represent basic data like whole numbers, decimal numbers, characters, and Boolean values. Fixed size, platform dependent. While the standard defines minimum requirements, the exact size and range of primitive types can vary slightly depending on the specific compiler and platform being used. Okay, so that you have an understanding. Right, I'm Windows 11 now. I'm on an x64. There is a way, if you type system on your computer or laptop or whatever you're working on, you type in system at the bottom, you can get the information. It'll tell you whether it's an x64 or an x86. That refers to the type of architecture. x64, pretty much these would be the memories, the amount allocated in memory for a x64 system. And then you would have a 32-bit. That's x86. Okay, that's the older. That's okay. Maybe people are still using 32-bit. I don't know. Okay, carrying on. Right? So, platform. That's what they mean. So, up here I have debug and such. What that really means is it doesn't mean that how do I express this? If I'm making a program or an application, this would be what I'm kind of designing the application for. I could change this to x86 and create even though I'm using an x64 CPU, I could actually make x86 programs as well. Okay, so that refers to who my end user is going to be, essentially. Direct memory representation. They often have a direct mapping to how data is stored in the computer's memory. Common primitive data types. Okay, let's just get right to this. Integer types, right? So here's an example. You have int. That's the most common, right, guys? If you're reading other people's code, Like, you could use these other ones if you need a broader range. Again, there's the differences between signed and unsigned, right? Take notice of that, right? Pay attention to those finer details. And if you need a smaller range, you could go with short, right? For example. All right? It's a way to save memory. Int. So you use int for general purpose whole numbers. Okay? Short. For smaller whole numbers, potentially saving memory. And then you have long for larger whole numbers. And then you have long for even larger whole numbers, right? Just depends on what you're doing. If you're doing small applications, you could still build your programs with int. You could do that. If you're not releasing anything, it doesn't matter, guys. But if you want to be kind of practice saving memory in that, and let's say, you're only going to be needing values up to 5,000 or something, for example, maybe you want to use short. It's up to you. Unsigned versions of the above. Okay, you have unsigned int and you have unsigned short to store only non-negative values. So that's what unsigned means, right? The way this kind of works, like one of the bits is saved for the sign in memory, right? That's why you have a different value here at the end, right? Because one of those bits is saved for the sign, right? And that's what signed unsigned means, essentially. And obviously, if you didn't sleep in math class, you know what a negative number is, and you also know how the integer grid works, right? Okay, and you can get wrapping with the values that we're using here, right? I did a video specific on that. You have to kind of follow the series to see that. I'm not going to get into detail about that now, because we're moving forward, right, guys? Trying to here. A lot of people have been following the series, and for them, I'm going to keep going, right? They've already spent the time. So floating, you have floating point types. So floating point types, just think decimal. Float for single precision. I do have that on here, right? There's a difference in range here. And this means to the power of, right? So what's returned to your console is, here it's saying approximately 7 digits. I have those numbers somewhere. I'll have to try to find that. I actually have it in my document here. And then double, right? Double requires more allocation in memory. And the range is huge, right? So you'll see float commonly used like in video games and that. One, I guess, requires less memory allocation, and you don't really need to be that precise or have super precision with gaming and that, like, because everything's kind of updated. I don't know how to, like, without going in too much detail, like, your screen is refreshed every second, right? 60 frames per second. Like, that's a lot, right? Your eyes can't see subtle differences that quick, right? So it doesn't matter. Okay, that's a gooey kind of breakdown a little bit, but anyways. So float is good, right? It's common for video games. And plus, you want a little bit of accuracy, right? Okay, double. For double precision, floating point numbers offering higher precision range than float, right? Just like I kind of said. I don't know, I imagine double would be used for something like some sort of company databases or something. I don't know. Something to that effect. They want more precision, right? And again, the range is like crazy. Like, you couldn't even count the stars in the universe. That's how many there are. Long double for extended precision floating point numbers. Okay, there you go. Long double. You can have long double as well. So it's not common, right? Again, the most common would be int, char, float, and double. Those are the most common ones you're going to see. Character types. Okay, for storing a single character. Okay. Example A, uppercase A or lowercase b, or the number 7. They're all characters. Every key that you press on a keyboard is associated with an ASCII value, right? So each one is a character. Even though it's a number, it's still a character. It's considered still a character, guys, gals, okay? Just, you have to kind of separate the mathematics way of thinking from the computer way of thinking a little bit. Okay, just think of every key that is on a keyboard is a character. So it often stores the ASCII value of the character. I'll do some ASCII kind of ciphering, deciphering, and those sort of things in the future, guys. Keep watching. Stay tuned. It is Monday, so of course it's trying to get back into the streaming groove again, right? So I appreciate your patience. You have WCHAR_T for wide characters used for supporting large character sets like Unicode. And you have char8_T, and you have char16_T, and you have char32_T, introduced in C++11 for specific sized character types like 8-bit, 16-bit, and 32-bit characters. Pretty much all them weird ones that you see. We don't really care about them so much, but let's see. Hold up. Let's see if I can find. I don't know. I don't think I have anything on that. Do I? These are all the normal ones that we use, so those are common. So that's not going to help. These ones, you kind of get all these weird characters, right? But they all have, this is the ASCII table, guys and gals, okay? Again, there's a number associated with them. Each character. Okay? For all intents and purposes, we'll probably just stick with the common stuff, char, right? We won't get into too much detail on that. If you want to research, you can research. I'll see. Maybe in the future I'll do something for you guys and gals. I'll just paste it right here. Okay? You can search maybe some examples. All right? You have Boolean types. All right? Boolean type, bool for storing logical values, either true or false, right? 1 or 0 respectively. You have valueless type, so void. Void signifies the absence of a value. It is primarily used to indicate that a function does not return a value or for generic pointers. Okay, you can return a number using a void function or method, but it's not returning a number. That number that gets returned could be used in further calculations. Okay, so I'll just paste this. I'll copy and paste this to save some time. So I'll just comment this out as well. And I want to clean this up, as a matter of fact. We're going to clean this up. If you guys and gals have been following the series, I guess I could have put it up there. I'll just put that up here, right there. Perfect. Okay? So if you've been following the series, you know what's up here. Okay? Again, I recommend you go back if you missed it. Check it out. How primitive types differ from other data types. Primitive data types are distinguished from other data types in C++ in the following ways. Derived data types, almost can't talk today, guys. I'm trying. Derived data types built from primitive types and including arrays, pointers, and references. I promise I'll get into doing showing some passing by value, passing by reference, and passing by pointer reference examples. We will. User-defined data types, complex types created by the programmer, such as classes, structs, and unions. Unions is not really a common one, but classes and structs are. Include IOStream, the standard library, right? Always at the top. Include string has its own class with methods, right? It's specialized. String is specialized. String is a series of characters. So think of a series, like a series, one after the other, okay, of characters. The standard library standard string is not a primitive type, okay, but a class that is a part of the standard library that comes with C++. Okay, so that's the distinction with string. It's not a primitive type. Okay? So I'll just kind of bring this over here. I already have my code and that set up for the what I'm going to type up today for you guys and gals. I already kind of do stuff ahead of time just to try to save some time. Okay, of course, all the different data types. I've got some examples here. I'm not going to torture you with the reading. You can pause or whatever. Take notes, take a screenshot, whatever you want. It's there for you. This might help a little bit, right? We'll talk about a little bit of this stuff. I feel like I need to talk about it a little bit before we kind of move forward. This kind of style here is with the C language. I'm not going to call it old because it's not really old. But if you think of a series of characters, it needed this null pointer. It's kind of like a stop for the compiler. The compiler needs to know when to stop, right? So that's what the backslash 0 does. No character. Okay, string, you don't have to worry about those things. It's already kind of there. You don't even see it, but it's there in the background. It's kind of a, when the compiler's reading the information, it needs to know when to end, right? Okay, bools, right? Think true or false. Okay, again, Boolean values declared true or assigned a value of 1. I was going to show you a little quick example. That's why I wanted to talk about this a little. And false values are assigned the value of 0. Okay, no, we're not referring to binary numbers here. At least I don't think so. I'm not really running it, so. Okay, strings, not really getting into strings just yet. We will talk about strings a little bit more. Recall that variable itself holds or stores a number value into memory. It's the same with bool. We have assignment operators. So just kind of an update on that, right? Just things that we're going to be using. We're going to eventually start grinding out different various code. And I feel I need to talk about this now just to get it out of the way. Okay, five assignment operators, the common ones, right? Arithmetic or binary operators. These are things we already all know from, learning in school. Right from elementary, I imagine. Equals, plus, minus. Take note that you can't use X for multiply, right? because X can be a variable, right? It would just create confusion. So I imagine they overloaded the asterisk operator, because the asterisk has to be overloaded because it's used in so many different ways, especially with pointers. And it does two things. It creates a pointer and it actually used for dereferencing, but we'll get into that. And obviously, guys and gals, this is something I got to be clear with. I don't know, a lot of people, that's why I always say, don't sleep in fractions class. What does divide mean? Right? Think about it. What does divide mean? Here's a fraction, okay? 20, I should have reduced it, but let me just, whatever. It's going to be 3/4, right? Divide. So what does divide mean? It's a fraction. I don't know why people forget that part. That's why I always say don't sleep in fractions class, right? A lot of people do these kind of internet problems solving it in a linear fashion. I kind of cringe on that, being a math major, because you don't do, I don't know. You just don't solve if you have a divide sign. I have an example that I could, but I'm not going to get into that and share it right now. Maybe in the future. Stay tuned. But you solve the problem with numerator over denominator. That's kind of what I'm getting at. Okay? And the compiler uses PEDMAS rules, so I recommend using brackets if you want to create separation between your numerator and denominator. It'll just make certainty that your answer or result will end up being true, right? You want the correct information outputted, right? Need some more coffee. All that talking just makes you thirsty, you know? Okay, back to it. Fmod, we're not going to get into. Whoops. Just give me a sec here. Just going to scroll here. Okay, here we go. Yeah, so hold up. I want to actually make sure I finished there. Did I finish? Well, you could have kind of read it, but I recommend, again, if you have a weird formula or a mathematical computation, just make sure you separate it with brackets or parentheses. To finish off, the asterisk is times and the / is divide, right? Because obviously there's no fraction straight line on our keyboard, right? I mean, I guess that could have worked, but that's minus, right? Okay. Modulo, just think remainder. And I did an example here. I know a lot of people this scares them off kind of stuff, but I did that. This is an example. It's a nice little visual for you so you get the idea, right? You can get weird results. Like modulo is one of those things you kind of have to play around with. I believe I did a bunch of examples. I talked about modulo in the past streams. Pretty sure. All right, bringing this back. So and then you have your comparison operators. Comparison operators always go inside parentheses. Okay, it's kind of our test condition. Like for example, maybe an if statement. Yeah, not a for loop. That's different. An if statement. It would be if and then brackets, open close parentheses, and then inside you would put your comparison or your test condition, right? And these ones are for comparing one to another, right? Just like greater than, less than. this is stuff, mathematics, 101 stuff, right, guys? Okay? I'm not going to read all that. It's there for you. And then you have logical operators. Kind of, whoops. That doesn't want to scroll nicely. So, I don't know. I'll just stop there. Logical operators, right? You're comparing kind of a left side to a right side. You could have two test conditions and compare two test conditions with each other as well. You could do these kind of sort of things. Here's an example here, right? So I could use more brackets, right? This is what I mean. So now I'm creating kind of organization and separation, right? Between a left side and a right side. You kind of have to think like that a little bit, right? So now I'm comparing if x is equal to 8, and means the left side and the right side have to both be true. That's what and means. Or just basically only one side has to be true. Okay, but with and both sides have to be true. Okay? And then you have the not, which means, well, it's just the opposite. I can show you a wild not example, but I don't want to kind of I don't want you guys running away too soon. But as we get more advanced, I'll try to recall in my mind to do that not example, okay, that I have. It's pretty cool. It kind of gives you a deeper understanding on how to use nots. It's wild. I love it. My point, the gist of it is a not can cancel another not. It's a not. And then increment operators. Now be aware you have pre and post. Okay? I kind of use pre more because I think line by line, it's the calculation is done immediately. With post, it's kind of line by line. It's almost like it skips a line and then does the calculation. Under the hood, I don't know. It seems like that. But this is my example here between the difference between post and pre, right? In regards to the output. You can try this yourself. Copy this exact code while excluding, the notes here, but you're going to want to copy this. Just type that and then type that and then create a standard cout separator if you want, right? You could do this, create a standard cout just to separate. Okay, if you wanted to. And then you can kind of get an idea like what's happening line by line, right? Kind of messes with the brain a little bit. But I use pre because from my way of thinking, the addition step is done first. Okay? Is there anything more? We talked about urinary and ternary a little bit. I guess I could show that a little bit. I want to get through this. Kind of reviewing the stuff I talked about in the past. I've showed you the binary, and then you have the urinary as well. Here's the binary scope, which is the common one. And then we did ternary as well. This is an example. I like ternary because you could use it. Let's say you only have an if and an else, and that's all you have. Let's say you just don't feel like using if else today. You could use a ternary, right? Now, if you have multiple if else, well, obviously you can't use ternary, but I guess you could use a ternary operator inside an if else. Just depends on what you're doing. But this is only to replace an if else. That's it. Okay? So if you don't feel like using an if else, you could use a ternary. Bit of recap. I didn't talk about while loops in that yet, or for loops. We'll get there. We'll do that soon. That's kind of a recap. And then I'll share this. If else, right? Test condition, right? That's when you use your comparative, right? Your equals to, or less than equals to, right? It has to be true before it enters the block of code. That was kind of the old school way I used to type these. Anyways, I'm going to leave it. I don't want to mess around with it too much. I was using the other style in the beginning. So that's the only difference there. It's just a style. It's another way of writing your statements. That's all. Okay, guys? There. That's a quick recap. Now, I'll do a couple of examples here. Let me just clean up first. That's a good idea. Let me clean things up. What am I going to do here first? I'm trying to recall. Some of my older stuff that I typed up, just kind of screenshot it. Okay. Let me do this. We're going to get rid of this cat manager class. I'm going to kind of start it again. I'll show you how to clean up. So if you want to know how to clean up your program and create a new class, you can. Whoops, I didn't mean to build it. Okay, and then I have to make sure the main is cleaned up. I think it is. I don't think there is anything. So now I've deleted everything. I don't need to do that, but I just kind of from habit, I do. So now I'm in the Solution Explorer. Right click, remove, delete. Make sure you are in, well, I guess it doesn't matter. It doesn't matter. And then same thing, remove, delete. Okay. And then the next thing you do is just click up here. This is your project name. Click above it, right click, clean solution. Okay, boom, cleaned. That's something you must do. Okay, otherwise you're going to have like all these dependency conflictions and such. Right? If you're using the same program, I mean, if you're creating an application and you don't plan on removing the classes, you don't need to do this step. But if you're going to keep reusing a program, like a practice program, let's say you called it practice, right? You're going to be changing it all the time, right? Things get saved on your file explorer in the system under the project, right? So cleaning it up is a good thing to do. So now at this point that I've done that, I'm just going to build it. Okay, right? So here's the last thing that I forgot to do, right? It doesn't know about it. I just deleted it, right? So what it's basically saying is you have this here, but it doesn't know what it is, right? So that's all I have to do is just get rid of that. Done. Dependencies, that's what that is. And bye-bye, clean. Brand new clean project. All right. I thought I updated something. Okay, to the recent follower. Is that not? Did I get rid of that? Hold up. It's up top here. Oh, okay, there we go. All right. It's at the top. Nice. Okay, I organized a little bit. I forgot about that. All right, Rough Riders Gaming, welcome to the channel. I couldn't hit you up. I wanted to hit the follow, but I couldn't. I was just unable to, bro. I did want to. I tried. What the heck is this I got on my table here? All right. So I'm going to type up a little example here that I kind of did in the past. It's not like doing bools, but it kind of gives you an idea here, okay? So I've given you a few examples here. Int age is 30, float prices, a floating point. What do they call it? Floating points. I just want to make sure I use the floating point types. That's what it is. Yeah, floating point type. Okay. And every floating point in C++ ends with an F. Okay. It's C# has another kind of way of doing it. I think it's still F for float, but anyway, C# also has these where you can add these little I'm not sure what to call that, to be honest. I just know how to drive the car, okay? And then double pi, you could actually, type all the numbers if you wanted to. Char initial, char is just a single character, right, guys and gals? That's it. And bool is, you assign it true. And basically, you're just saying 1, essentially. That's what you're saying is 1. Okay? Because true is 1. Alright. So, I'm just going to type some new ones up here. I'll leave these just for you guys and gals. And I'm going to go int num1. I don't really need to go num1. Equals 5. Okay? We're going to do couple of little examples here. Okay, so I created declare, initialize, declare, initialize, declare, initialize, declare, initialize. Okay, data type, variable, and initialization. Okay. What else do they call these? There's so many different random names and things that everything's called. I just call it a variable. Keep it simple, right? But they also call these symbolic constants and these literal constants. Okay? Just other little things to remember. Okay, alright. So let's just do this. I'm just doing some reading there to see if it was kind of important to what we're doing, but it didn't seem to be. So I'm just going to use brackets, and I'm basically typing a test condition right here, right? Just so you understand. I could do this without an if statement or an if block, right? In a sense, that's kind of what I'm typing here. If I could type condition. So what I'm going to do is comparative, right? Num is less than or equal to num2. Okay? And then I'm going to go like this. And to clean the buffer, I'm just going to do this here to clean the buffer. Okay, there we go. Could have cleaned it after, but I guess it doesn't really matter. Should be cleaning it kind of down here. There we go. Enough. Clean it at the end. Okay, so, and then I'm going to do another one. I'm just going to copy this. And this time I'm going to go equals 2, okay? You can see our values here, so I'm just going to go like this, just so it's nice and clean and you guys can see this without any confusion, okay? So our variables, num1 basically is 5 and num2 is 8, okay? And if you look at it and you didn't sleep in math class, you're going to know that num1 less than num2, because it does both, right? When the compiler goes into this test condition, it has to do both checks. Is it less than? And also if it's equal to, right? It might actually just go, is it less than, and actually just continue on because the 1 is true, right? We know that num1 is less than num2, right? That's true. So technically speaking, I don't think it even needs to check the other one. It could, I guess. Probably does under the hood, I imagine. So it checks that. Is it equal to? No, it's not. Okay, so then our second line here is num1 equal to num2, which is not true, right? So what do you expect, right? So we know left side is true for our less than, and num1 is false for the equal to, right? You guys following along? And this one here, is it equal to? That means that's kind of being like explicit. Is it actually equal to? It's essentially what that is. Is it actually equal to it? And it's not. So it's going to be false. Okay, so what does true mean to you? And what does false mean to you in a numerical sense? Okay? True, just like Boolean, is equal to 1. False, just like Boolean, is equal to 0. Okay, that's kind of like a breakdown right now on Booleans. Alright, so I'm going to run it. Let's build it. And because I'm using a standard CL, it's going to return something to the screen, right? What's it going to return? It's going to return, again, this is a test condition, so what does it return? It returned 1, then 0. It's going to go like this. Because the left side was true, it returned 1, right? So in essence, it kind of just ignored the second one. And the second statement, well, it's just a singular comparative operator. I got to use the terminology right? It gave us a 0. Where is that? Where is that, Bob? Comparison operator, right? It's just it's an equal to comparison operator, right? It's basically a singular, right? This is 2, right? It has a less than and an equal to. This one's just like an equal to. It's kind of like, is it absolutely equal to it? You know what I mean? So it gave us 0. So you can do that, right? Look at this. This is just a test condition. And take note of the return. The return is 2 numerical values, 1 and 0. That's what that means. So when you get returned to the screen and you're wondering, what does this mean? That's what it means. It means true and false. Essentially. All right, guys? So that's kind of like a little bit of a breakdown. And let's see. Let's do some more. Okay? So you get that idea, hopefully. I'm just going to paste that up here. Bool is what you use. Okay, and I'm done with this. I'll just delete them. Okay. All right, so let's do another standard cout. Just doing some examples, and then I'm going to get to writing that class. Just wanted you guys to, have a little bit of understanding of what you can expect when you do different things, try different things. What is it you're seeing in the console? What does it mean, right? In essence, that's what we're doing here. Test condition brackets, num. So num is equal to 5, I have. And then I'm using and num2 equal to 5. And then there. Okay, whoops. Yeah. Typing fingers, okay? And then I'm going to copy that. And I'm going to use or. It's the double pipes. So here I'm using and. And I'm just going to copy this. Go or. Okay, let's see. So we have num1 is equal to 5 and num2 is equal to 5, right? Remember, it's going to compare, right? And the and means this side has to be true and this side has to be true. So both of these have to trigger a 1 and a 1. Make sense? It has to return a 1 and a 1. And here it doesn't matter, right? Here it doesn't matter. An or is only one side needs to be true. So if this is false, it'll check this. If that's true, it'll return 1. Okay, and then let me show you the not. I'm going to copy this. And let's use not for the first time. So, as you can see, I'm using brackets, right? I have a left, I call this the brother and the sister. Okay, they belong together. So, it's a single set of brackets. Everything's inside. Okay, so I could put a not, which is the exclamation point. Okay, that means not. So what I'm saying here, I'm basically switching this to an and, if I recall. If num is not equal to, instead I could actually put the not equal to there. So what I've done here, in essence, is I've made it this exactly the same as this. But I'm going to leave it at that. I don't want to confuse you guys, okay? I'll see if I can find that example, and I'll show you in the future. Okay, but let's just get the basics understood, right? So I'm putting not outside the brackets. That means everything inside is not. Okay, everything. I've made everything the opposite, essentially. Okay, so we should get a return opposite of what this is. That makes sense? So this is going to return either a 1 or a 0. And because I switched it with a not, it's going to be the opposite of this one. Okay? Hopefully that makes sense. I don't want to over-explain it. There we go. You can see the middle one. The middle one returned 1. And they're the exact same thing inside, but I switched it. That's what I've done. So I'm going to get the opposite. So let's kind of have an understanding here what's going on. So if num is equal to 5, that's true actually. And then num2 is equal to 5, that's false. Okay? Therefore, it returns a 0 because it's an and, guys and gals, right? Remember, both have to be true in order for it to return a 1. So that's why we're getting a 0. Okay? Let's check this out again. Num1 equal to 5? That's true. Okay, so that's a 1. Is num2 equal to 5? That's false. Okay? So it returns a 1 because it's an either or thing, right? One of them is true, so therefore we're going to get 1. That makes sense? Okay, because one of them is true. And it's an or. It doesn't matter. If one of them's true, it just returns 1. It doesn't even need to go into this because it's an or. Right? It sees the or and it goes, this one here doesn't even matter because this is already true. Okay, so now this one here, I've switched it, right? I've flipped it. Essentially, that's what the not does. It flips the switch. Okay? So num1 is equal to 5. Essentially, I'm saying, is num1 not equal to 5? That's what I'm saying. Is num1 not equal to 5? Well, that's false because num1 is 5, right? Or, right? Actually, and that's why it returns 0 because this actually became true, right? Because num1 is equal to 5. So does that make sense? I hope so. Essentially, it's no different than me going and putting the not here. Okay? Is num1 not equal to 5? That's false because num1 is equal to 5. Make sense? I'm going to leave it at that. I don't want to over-explain it too much. Okay, so because it's an or, we get 0. And I'm going to change that back. Okay, I had the console run and I'm changing things now, but does that make sense? I don't want to over-explain this. I have a pretty good example of breaking down a not and to figure out if the final answer is going to be 1 or 0. It's pretty cool, but I'm not going to share that right now. But hopefully that makes sense. Okay, that's using not in a nutshell. A lot of people don't like using it, but I don't mind using it. It just depends on how you want to use it and what the circumstances are. Okay? Again, just remember, the not flips the switch. It makes it exactly the opposite of what the one above is. Everything here is exactly the same inside. Right? Alright, anything else to do here? Note that a result of 0 equals false and a result of 1 equals true. Okay, and I could even type a little program too if I wanted to and compare doing user input. I want to see how much time we're at here. Buongiorno, let's go. Love you too, brother. Oh, wow, where does the time go? Yeah, I definitely have to move on. Buongiorno. All right. Okay, I'm going to leave it at that. I just thought I would share some, kind of quick examples. Quick drink of coffee. All right, I'm going to do up a little bit of a OOP program here. And this class actually went a lot faster than I thought it would. Wow. Whoops. I was supposed to go, I got to get this other stuff done too. I got to finalize this. I don't want to start another stream on this. Okay, I need to get it going. We might go past 2 hours, guys and gals, just as a heads up. Hopefully it's not too far in. Trying to keep the course/lectures around a couple hours. Again, I probably talked too much in the beginning. If you're following and watching the series, by all means, it's not going to hurt my feelings if you skip right to learning. I don't mind. That just tells me you have a pretty solid, awesome character if you just want to get right to learning. That is great in my books. Okay. We're going to clean this up. I'm going to get rid of this. Just a quick build. Run. Good. Let's go. And all right. So now I'm going to create a couple of classes. I could make these a struct. I could. I mean, it's a point manager, and we're just going to be doing something with a singular point, right? So, if you understand the coordinate system, right? Just like in any game, an object moves in space within the game, right? Whether it's 2D or 3D, it doesn't matter. It still has XY coordinates. Guys, math is fun. I love linear. Oh man, don't get me started. I'll do literally trigonometry if you get me going. That stuff's easy for me. Trig is basic. But anyways, so I'm just going to create a little program. I'm going to create a namespace. It's going to be called Point Manager. All right, I got most of this typed up. I might have to do a bit of copying and pasting maybe to speed things up here. New item. As a matter of fact, I prefer to do it this way. I want to switch from, this is the virtual. I want to switch to the real. Okay, just by clicking this button here. So now this is the direct link to your file explorer. Okay, I want to make sure that when I create my new item, it's in the source file. That's why. Okay, Point Manager, add. So what goes with a source file? Always a header. So I'm going to add my header. Header. Same name. Okay, boom. Done. These two belong together. Okay, they come in pairs. All right, so what I'm going to do is in each one, I'm going to create a namespace. You don't have to do this. Something I like to do. I'm going to go like this just to save some time. I like to do this organization stuff, but for all intents and purposes, whoops, I didn't mean to do that. Okay, namespace, there we go. And I don't know, I like doing this just so you guys and gals know that we're at the end. Okay, that's the end. All right, done. So now I'm going to do the exact same thing in our source. Okay, I have to include the IO stream because I'm going to have a standard CO. That's the reason. Otherwise, you don't need to. It doesn't need to be in there. Okay, the reason I always add it in my header. That's why I got these notes for you. Okay. All right. I'm going to create the namespace inside our CPP file as well. But let me do this first. First thing you want to do is include. Okay, I'll type it. Okay, include. Oh, it's a hashtag. Don't forget to hashtag it. Hashtag include. Wow, it really broke there. I'm just going to undo all that. Hashtag include and point manager. I'll just type it .h. So we're including, I could have tabbed it because actually it brought a drop down list. You see that? Point manager Is it going to bring down the drop-down list? Of course. Why would it? Why would it? You've seen it there, but I could have just tabbed it. So make sure in your source file you include your point manager header file. Okay? That's the link, right? It needs the link. It's part of the linking process, boys and girls. Part of the linking process. And then I'm just going to copy this because, you know, I want to make sure I don't have any typos in there. I know I could size these up. I don't know. Are you guys fine with it being this size? I hope so. All right. Just build. We should be good. I do have to include that also in my main. Okay, don't forget that. And I always put it at the bottom, underneath my IO stream. Okay, you have to include it also in your main. So when you do it here, you might as well just copy it and go right to your main and do that. Okay. And then I'm just going to end this. There. Okay, first thing we're going to do, I usually start with my header because this is where we do our declarations, right? So, class, okay? Create a class. Again, I could create a struct. Doesn't matter. I'm going to call it a class. Class and struct, basically the same thing. But one is public access from the get-go, and the other is private. Okay? Class is private, therefore I have to type public. It's a must. Okay? If you want things to be public, you must type public. And that's where my private variables go at the bottom. It's the way I like to do it. There we go. Now we have a class inside of a namespace. Alright, so now I'm just going to go like this. No constructor. So what does that mean? No default constructor means this. Okay? Right? I'm not going to have a default constructor. This one is a parameterless one. Parameterless. Okay? But we are going to have one. I like to put these notes for you guys and gals. Okay? A default constructor with a parameter list. What does that mean? This. Always, your constructors have the same name as your class name. Always. You don't even have to think. Okay, so parameter list. What is a parameter list? It means we're passing in arguments. So we have to give the constructor some parameters. And those are going to be float data type because, well, they're coordinate system, right? They don't use int for a coordinate system. It's float. Okay? All right, so down here it's saying function definition for point not found. Well, all we need to do to fix that is create declaration and definition. Boom. Going back to here, so I'm going to go like this, and 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 just move that up. Whoops. All right, there you go. And common thing, nothing here. All right, there we go. So if you notice, I didn't put any variables here. There's no variables, right? Okay. When you, just like the main, we don't need to put variables, right? The variables are down in our definition, okay? Which is part of our source code. It's the same thing, right? This is the header, and this is the source code, the definition. Except we just have everything in the main. I want it to be part of the main, so I'm leaving it there. Okay, class we're creating separately. So what am I using for variables? Well, first I need to create some member variables, private ones. All right. And just to save some time, I've already typed this up, guys and gals. Okay, there we go. Float M, it's X, and float M, it's Y. Okay, and okay. And then common stuff I'm gonna have my methods, I'm gonna have my accessors, whoops. Common stuff. And there we go. And I'm gonna go like this as well. Boom. Okay. So I do need to explain still the difference between stack and heap allocated objects or variables. Okay. We're just using, for this example, we're just going to do stack allocated. And when we get to the main and type that up, I'll show you what a stack allocated looks like. Okay. So I put these notes here. You don't really need when you're using stack allocated objects, but we're going to add it anyways. When you create a destructor, it always begins with a tilde, same name, brackets, and that's it. That's all you do. Okay? Tilde, same name as the class, your parentheses, and semicolon. All statements end with a semicolon. Okay, we're going to create our declaration. I don't need it, but I just want to show you how to kind of make the magic happen. If you want to see if your constructors are doing its thing, same thing with the destructor. Let's go here. I'm going to go like this. Okay. That's here. Okay. And then normally you would just put this inside. Okay, nothing here, right? Always nothing here. But if you're at home and you're just doing code yourself and nobody's going to look at it, you can do this, what I'm about to do. So if you want to see your constructors working and your destructor working, you could do this. You could actually take this from me and utilize it. I do this standard C out. That's why I had to add the IO stream, was for this. Okay, and then I do this for my destructor. This symbolizes my object being allocated, and this symbolizes my object being deallocated. That's the job of the destructor, to clean up the memory. Again, we don't need it for stack allocated. It's all done for us and behind the scenes. We don't have to think about cleaning up or doing housekeeping when you're doing stack allocation. Okay, but for heap allocation, you must. Okay, just as a heads up. You have to become your own housekeeper. All right, there is a program I can show you. You could actually just use it all the time, and it does all the cleaning up for you, and then you don't have to worry about doing it in the main. But we'll get there. You're gonna have to stay tuned. All right, keep showing up, keep watching, keep up the views. I'll keep going for you guys. Okay, your guys' commitment equals my commitment. I enjoy doing this. If you're dropping by and checking it out, learning and watching, I'm glad to be doing this for you guys. 100%. Don't forget to buy me a coffee. Let's go. Okay, so we have our default constructor. It's taken in 2 parameters. Stay on point. Get the pun? I'm being funny. I'm being punny, guys. Okay, and we're not finished here, right? I'm not finished with my default. There's still things missing. I still have to do my variables. And they're going to be called it's X. I'm using all lowercase just to differentiate between my private ones. That's why I always do the M. M is for member. The underscore to me infers private. Okay? They may not mean something to certain people that are like looking at the words, and to them they're just seeing words, right? There's meaning behind it. Okay, so I'm just using all lowercase for my variables. These are going to be my passing in variables for passing in. Okay. All right, so now we're using the member initializer list, colon. If you've been watching and following, you know the reasons and reasoning behind using a member initializer list. Okay. I'm going to just copy that. I'm going to go like this, brackets, left side, comma, because we have another one. I'm a bit of a lazy typer, guys and gals, and I don't want any errors, so just quickly double click, copy and paste, and there we go. That's done. Okay. Now it's saying it's not recognized. If you see this, all you need to do, guys, gals, just go to back to your header, and it'll clean up. There was a squiggly there. Okay, it's gone now. Now, if you're wondering what these ampersands are, this is the and sign. Again, it's another overloaded operator. This doesn't mean and, guys. This is passing by reference, okay? Here I'm passing by reference. Okay, this is an example for you. Okay? Remember, passing by value creates copies. Copies, no bueno. That's duplicating. It's more stuff you're smashing the memory with. Okay, there's only so much space. Well, there's probably lots of space, but it's best just good coding practice. Plus, you're going to have a program that runs smoother, flows nicely, probably even flows and runs quicker. Well, it would. We can't really tell because it's probably most likely in milliseconds, right? So as a human, we don't really pick up on milliseconds, right? So, but every millisecond matters, right? Just like adding numbers together, it all adds up. Okay, guys? It all adds up. Okay, so if you're going to hypothetically release your program, I recommend at the end you could delete those, right? Or you could just comment them out. All right? It's up to you. But again, these are just for testing, and so that you can see that your object is being created via the constructor and also being deleted via the destructor. Okay? Now, why do I put these extra curly brackets in main? This empty scope? It's because I want to see the destructor. I want to see the memory being cleaned up. Okay, hence why we're using the empty scope. Otherwise, it would get this. Remember, guys and gals, when it gets to the sister bracket, that's it. It's done, cleaned up, right? So once it gets to this point, it's not going to show the C out for the destructor, right? When it gets to here, it's not going to print it out. It's done. That's a full stop right here. Full stop. But because it's not a full stop here, it'll actually return this C out. Okay, make sense? Hope so. Again, you don't need the empty scope, but for all intents and purposes, so you can see your destructor actually working with your program, right? You're not going to see anything now. I'm going to run it, right? Why are we not seeing anything now, guys? I'll let you think about it. Hold up. Do I have that? I gotta have that. Just hold up. This is fun. I like doing this. Let's see if I can find this. Dun, 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 dun. Come on, please tell me I have it. Please tell me I have it. Where did I put that? I swear to God I saved it. Doesn't look like I did. Oh, I did. Here we go.
Nope.
Hang on. We got a commercial to skip here, guys. This is the thinking step for you. I love doing that. Why, guys? Here's the answer. Because we have not created a stack allocated object yet. I don't mean to yell at you, but that's why. Okay, how do you create a stack allocated object? Easy. What's the name of our class? Oh, it's points. Going back to main. There we go. There's our type. Oh yeah, I know. I think I know. I'm missing one more thing in my code. I could already tell. I could tell because just from grinding enough code, I know that the program's not seeing this yet. It's not recognizing it, which is telling me that I've missed some information, which is part of the linking. Okay, so I'm going to create an object called P. That is a stack allocated object. Okay, I could use obj. I could use POBJ. I could use PB and J, because who doesn't love PB and J, right? Again, you're the creator of the object name. So what I'm missing is this right here, my namespace. Because I created a namespace, I'm also need to say I'm using the namespace. Okay, there we go. All right, so I'm going to build it right here, right? No appropriate default constructor, right? Because why it's doing that, guys, is because I'm using a default destructor, and we don't have a default destructor. Okay? A default destructor doesn't take anything. Okay? So our object is going to match, right? A default destructor is basically no brackets. Okay? So our object doesn't need brackets, right? So if I use brackets, that means I'm using the default constructor, but we don't have a default constructor. I still need to pass in variables. Okay, so we're not quite done yet. I'm just going to comment it out. I wanted to run it, but because I'm not quite set up yet, let's just get set up. Okay, and then I'll show you these being utilized. These won't print until we create an object, guys and gals. Okay? We need to create an object first in order to utilize our constructors. Again, a default constructor, we don't need to type it in here. We don't need to put it in here, right? But we can. Okay, a default constructor, we can set it up to have default values. We can kind of do whatever with it. But again, that's the duty of the constructors, to set up our object. That's its duty. All right, let's continue. We need sets and gets. We have our private variables. We still need setters and getters. Okay, so let's do that and get finished. So I'm going to speed things up here because I've already got it typed up. There we go. I'll leave that for a sec if you want to copy it. Let's pass that to our source file. These are our declarations. We need our definitions still. Okay, quick actions refactoring, create our definition. Okay, going into here. Should be here now. There we go. So now I'm going to go like this. I do this for you guys and gals just for organization. Okay. All right, there we go. There's our first set for our getter point X and our set. You don't have to create a set if you don't want to set the values. It just depends on what you want to do with your program. Okay, there we go. That cleans that up. Now we have to do the other one. Same thing. I like to do kind of in pairs. I don't want to do too many at the same time. There we go. There's our other set. Go back to our H file just to get rid of the errors. Hang on. Oh man, sorry guys. I had to sneeze there. And I didn't want to, sneeze all over you. That would just be rude. Okay, go back to our header and it'll clean it up. There we go. Bye-bye. Even though we told the program to create it and then it put it here, it's almost like it still doesn't know. For some reason, I don't know. But don't ask, just do. Okay, there we go. So now we have to finish up, right? Finish what you're doing. We're going to return for our X. We're going to return our X. And same thing with the other one. We're going to return our Y. And remember, we're passing in, right, guys? Right? With our setters, we're passing in, right? That's how you change. Getting is const because we don't want that value changed. Hence why it's const. Avoid, set point, we can set it. We can change its value. Here, it's being modified. Right? Because we're passing in, right? So we're modifying a value. Okay? Same thing with here, okay? Okay, back to here. So I need my variables, which I'm just going to use the exact same ones that are here because it's not going to hurt or harm things. So left side equals right hand side. Done. Left hand side equals right hand side. Okay, we're basically passing in whatever information's passed in with X and whatever information's passed in with Y. We're leapfrogging. I like to call it leapfrogging. I don't know why, it just works. So I'm passing from the right hand side to the left hand side. So I'm leapfrogging. Boom. We're making that hidden variable now have a value. Okay, makes sense? That's done. Our setters and getters are done. The last thing I need is to print. Okay, I haven't showed you guys how to print yet. You can. Okay. Do we have it here? Yeah, I do. Okay. So I'm just gonna kind of shrink it up. It's a very small program. The main things are you could either have a default constructor or you could have a default constructor with a parameter list. Technically speaking, you don't need a destructor. Definitely do if you're newing up or heap allocating an object. Always create setters and getters. Now, you don't always have to. You would always create a getter at least at minimum. You don't need to create setters. I guess it depends on what you're doing. You always are going to need, without these, the rest of the program's useless, okay? Right? All the magic happens beginning right here, right? Again, the object is what kind of makes the magic happen, but without these hidden variables, everything's useless. So let me go here. What's going on here? What did I do? Oh, right. I know what it is. Silly me. I have to update here as well. Okay. That was my bad. Okay. It should get rid of. Be gone. I'll probably have to build it. Yeah. Be gone. Errors. That's it, right? I just forgot to pass in the variable, right? Again, you don't need a variable on the header side, right? But you definitely do in the definition side. Okay, so this is our X, and this is our Y. All right, so now let's create a method for printing. Okay, and you can make them const as well, guys, so that the value printed is unchanged. There we go. That's actually our method. So I'm going to just go like that. There we go. Okay. And shrink this up. And to save time, I'm just going to paste it in. My print statement. This is behind the scenes print statement. So I'm printing my get. I'm printing my get. And I'm printing my get. Okay, guys and gals, you see it? So when I pass all that in, when I do all the leapfrogging magic, passing things in, I can print it back out to our console using our getters. Now you're actually seeing how you can utilize your getters. Okay? Now I'm using this as a kind of a test print, if you will. As your code progresses, it'll get better. You may just use your gets in a different fashion. I don't know, it just depends on what you're doing, right? I could show you some pretty wild code, but we only have so much time here. But yeah, you can print back just using a void statement. It's const, and just return back to the console. Get point X. We're calling this method, right? We're calling the method inside. All right. Go back to my header just to clean that up. That's pretty much it for the code. That should be it. That's just a basic, what you would call boilerplate. Basically, I just boilerplated a program. Basic. That's your basic boilerplate code. Okay. Going to main. So now we go to main, and then now we have to do the magic in the main. All right. So, our class today is actually, well, we've done a few things. We've done primitive data types, right? And then we're kind of working on a point class, okay? For all intents and purposes. Okay, so now I'm gonna undo that. So When it's typed like this, guys and gals, right, this means default constructor. I don't need to put the brackets there, okay? The program's intelligent enough to know that it's going to use the default constructor, okay? So I'm going to do this just to speed things up. I'm going to create some local variables. Just going to clean this up, and yeah, good enough. All right. And I'm going to create a couple of variables. They're local, okay? Local variables. They're local to the main. Okay, I've initialized them to the value of 0. I can set this up to where a user enters values, but to speed things up here, I'm just going to do this. Maybe we'll do it tomorrow. We'll see how it goes. Actually, tomorrow I'm not going to be live, so I do apologize. If you're watching the series, maybe I recommend go back to a video that maybe you wanted to go over and watch again. I recommend you do that, right? Just to fill that day. And then I'll be back. Okay, again, keep it up. Keep being awesome. Keep watching. The views help, guys. You guys are killing it, Twitch. Much love, every single one of you. Thank you. All right, so now we have to actually put our constructors. We want to take advantage of our default constructor with a parameter list. Okay, we're going to be calling this constructor. So I'm going to pass in x, comma, y. Okay, these are our local variables in the main I'm passing in. That's it, guys, right there. So now we're set up. We're not going to have any issues with the program saying your constructor doesn't take 0 arguments, right? It's right what it says. This actually takes 2 arguments, right? Because that's the way we set up our constructor, to take in 2 arguments, which is a float and the float. Again, the data types have to match. So if you're passing in information, they have to be floats. Okay? We're passing in a float. You see? Passing in a float. We're passing in a float. Right now there's 0. I could actually print it now. Check it out. So objects, remember the objects make the magic happen. Press the object name, which is P. Dot separator. There we go. Now we have access to everything in our class. Okay? I can set right here as well, guys. I could set. But what I'm going to do first is I'm going to print the entity. So I'm going to tab this, tab, brackets, semicolon. Boom. Build, run. We should get zeros. Let's go. Let's go. Take note, guys, gals, take note. You see now? Now that we've created the object, our constructor is being called. Seeing these right here tells me automatically, immediately, that I'm using my default constructor with a parameter list. Right here, I have to actually hit an enter here. This is telling me automatically that I'm also cleaning up my memory. Well, I'm not doing it. Because it's stack allocated, it's done for me, or for us. But this is showing that it's actually being done. It's being called. Now, how do I create that enter? Weird sauce. Calls the object. Hold up. I know what it is. I think it's this. Let me just see. I have to update this. Control-Shift-B. Let's run it. There we go. Yes, perfect. That's what I want. Right there. I want it underneath the curly brackets because really that's when it goes out of scope at that point. Right? At this sister curly bracket is when it goes out of scope. This curly bracket here is this one right here. I just print it so that I know. This is this. This is this. This is this. Okay, I'm just printing it for funsies so you guys and gals can see it. All right. Let's change. How do you change values? Okay, we've declared them, we've initialized them, but how do you update the information? Okay, this is how you do it. So we're passing it in right now, but let's change it. Okay, so you just take the variable, right? We've already declared what it is. We only need to do it once. That's it. We've declared. Declaring's done. But we could actually reinitialize it to a different value. Remember, it's a float. So for example, I'm going to go 2.2f. There we go. So right-hand side equals left-hand side. This is a temporary limbo value, which will be passed into the variable. Okay? Remember, the right-hand side is temporary. It is stored, but it's temporary, and then temporary variable, if it's a variable, I don't know, under the hood, gets deleted after. Okay, there we go. All right, so we've reinitialized our variables xval and yval. They have new values in memory once it gets to this line of code, right? And then we're going to use our object dot separator, and we're going to set. Okay, now we have to set them, boys and girls. We have to set them. Normally isn't really done this way, but just so you can see, right? So we're going to set x, which means we're going to pass in x variable, right? Dot separator. Now let's do the one for setting y. Same thing, guys and gals. We're going to pass in y this time. Why? Because why not? Okay, so I can actually print this statement before the change, right? I can print the object. Remember, the object kind of it's taking in all the information. The object is kind of holding everything, right? So the object's going to return whatever the object is holding at that specific point in time. Okay, I can print it before. It'll give me 0, 0. And then the information gets updated, passed in, set, and then I can print it after, and I should see the new variable. So just to show you the before and after, right? This is the before, and this is going to be the after. And let's run it. Let's go. Drop the A's, because why not? Cool. Isn't that cool? That's cool. All right, we are pretty much done. We're kind of in overtime, but I need to finish up here. Let's see. Do put your class declaration. Let's see. I got to kind of read through this and speed up here with the summary so that I could go on to new stuff next stream, guys and gals. All right. Maybe that's too blinding. Sorry, guys. Maybe. I'll just leave it like that. Okay, or maybe I'll just leave you some reading notes here. Okay, there we go. Okay, there we go. Okay, now run the program again and compare blah, blah, blah. You're probably wondering why two keywords do the same thing. Okay, this is something where I'm kind of, I'm trying to move forward here. because I kind of did my own code and I kind of skipped what they had, right? When C++ was developed, it was built as an extension of the C language. C has structures, and C structures don't have class methods, okay? But Bjarne Stroustrup, the creator of C++, built upon structs, but he changed the name to class to represent the new, expanded functionality and a change in the default visibility of members, right? The public-private situations, right? This also allowed the continued use of a vast library of C functions in C++ programs. Yeah, that's great. I like it. Again, classes if you really want to go large and expand, but use structures if you're just going to have like primitive data. Right? That's kind of a recommendation. If it's basic and there isn't a lot, use struct. But if you're going to like have a class that's kind of and then go into like you can really go to pretty far and I don't know how to explain this. Like you could really go really far with classes. Okay, there's a lot kind of involved with it. All right, we haven't got there yet, but just to let you know, you can really expand on it. Okay, do put your class declaration in an 8.h file, header file, and your member functions in a .cpp file. Do use const whenever you can. I'm showing you guys and gals that right here. Okay, so that you're using proper right from the get-go. Okay, don't move until you understand classes. Okay, summary. Today you learned, actually the last couple of streams, you learned how to create new data types using classes. You learned how to define variables of these new types, which are called objects. Objects make the magic happen. It's amazing. A class can have data members, which are variables of various types, including other classes. A class can also include member functions, also known as methods. You can use these member functions to manipulate the member data and to perform other services. Hopefully you guys are getting all that. Class members, both data and functions, can be public or private. Public members are accessible to any part of your program, right? In the main, right? You see that, right? When you use the dot separator. Private members are accessible only to member functions of the class. Members of a class are private by default, right? That's why we have to use public. But struct, you don't have to. Struct is public. Whoops, didn't mean to do that. I wanted to leave that there for you. Right here, right? We have to be explicit with the public for a class, okay? All right, let's continue. It is good programming practice to isolate the interface or declaration of the class in a header file. You usually do this in a file with a .h extension and then use it in your code .cpp file, right? You're separating the declaration from the definition is what you're doing, all right? Nice and organized. And again, when it gets all kind of compiled for a release, that's all just changed to nonsensical wordage that only a computer understands. It's not even human readable. Okay? So that's your source file, right? It gets all kind of decrypted or encrypted, I mean. The implementation of the class methods is written in a file with the .cpp extension. Class constructors can be used to initialize object data members. Okay. Class destructors are executed when an object is destroyed and are often used to free memory and other resources that might be allocated by methods of the class. Okay, there's a lot of storing and what else not going on, right, guys? I want to finish up here. We're in the Q&A. Q&A part. How big is a class object? A class object's size in memory is determined by the sum of the sizes of its member variables. Okay? So again, it's just like A plus B plus C plus D plus E, right? Okay? Class methods take up just a small amount of memory, which is used to store information on the location of the method. It's a pointer, right? Remember in memory, a pointer? We've heard that, right? It's kind of the last position, if that's kind of what it's referring to. Going back to that, right? When you run your program on the stack, right? There's a pointer. It's kind of the last position so that if the compiler jumps into a function, it knows where to go back to. It's kind of like a reference point. Some compilers align variables in memory in such a way that 2-byte variables actually consume somewhat more than 2 bytes. The information they're talking about here is a 32-bit architecture. Check your compiler manual to be certain. Okay, blah, blah, blah. If I declare a class cat with a private member, its age, and then define 2 cat objects, Frisky and Boots, can Boots access Frisky's its age member variable? Good question. No. Different instances of a class can access each other's non-public data. In other words, if Frisky and Boots are both instances of cat, Frisky's member functions can access Frisky's data, but not Boots' data. They're independent of each other. Why shouldn't I make all the member data public? Okay, this is kind of cool. Good to know. Making member data private, and what they're talking about here is this, guys, gals. Okay. Enables the client of the class to use the data without being dependent on how it is stored or computed. For example, if the cat class has a method getAge, clients of the cat class can ask for the cat's age without knowing or caring if the cat stores its age in a member variable or computes its age on the fly. This means the programmer of the cat class can change the design of the cat class in the future without requiring all of the users of cat to change their programs as well. Again, guys, this kind of goes back to that cat type video I did. The cat type. It's kind of what we're kind of going over. We're at the end of this section, okay, in the course outline. If using a const function to change the class causes a compiler error, why shouldn't I just leave out the word const and be certain to avoid errors? If your member function logically shouldn't change the class, using the keyword const is a good way to enlist the compiler in helping you find mistakes. For example, getAge might have no reason to change the cat's class, but your implementation has this line. If its age equals 100, see out, hey, you're 100 years old. Declaring getAge to be const causes the code to be flagged as an error. You meant to check whether its age is equal to 100, but instead you inadvertently assigned 100 to its age, right? Even though it's in a test condition, because it's equal to, if test age is equal to 100, you're assigning it, right? Const keeps that assignment from happening. Because this assignment changes the class, and you said this method would not change the class, the compiler is able to find the error, right? It's pre-compile time, right? Or compile time errors. The kind of mistake can be hard to find just by scanning the code. The eye often only sees what it expects to see. More importantly, the program might appear to run correctly, but its age has now been set to a bogus number. This causes problems sooner or later, right? right? Sometimes them bugs in your code might be hard to find, right? Is there ever a reason to use a structure in a C++ program? In a C++ program. Many CPP programmers reserve the struct keyword for classes that have no functions. Okay, it's very basic. Structure very basic, right? This is a throwback to the old C structures which could not have functions. Frankly, it is confusing and poor programming practice. Today's methodless structure might need methods tomorrow. Then you'll be forced either to change the type to class or to break your rule and end up with a structure with methods. If you need to call a legacy C function that requires a particular struct, then you would have the only good reason to use one. Again, I haven't done a lot of C, so something there I've learned that structs didn't have methods. Things you learn. Some people working with object-oriented programming use the term instantiation. What is this? Right? You'll hear that, creating an instance. Right? That could be the words of the day, right? Hold up. Can't take that right now. Or instance. Okay. Instantiation is simply a fancy word for the process of creating an object from a class, right? Okay, and that's exactly what we did. Geez, go to the main here, right here. We're instantiating right there. Okay, a specific object defined as being the type of a class in a single instance of a class. Okay. It's a single object, single instance of a class. Okay, workshops. Here's some quick Q&A for you guys. You could do some research. Let's see, maybe I could copy this and just put it here. Okay, that's a 1. Tab. I gotta tab all this now. Instead of typing it up. Bunch of questions, research, guys and gals, for you, right? Okay. And then I'll just go like that, kind of create some separation. There's some questions, Q&A. Okay, or a quiz. Quiz. Right? Some research for you. You should hopefully be able to find the answers somewhere on the old interwebs. Write the code that declares a class called employee with these. Okay, so here's some fun for you. So if you need some ideas, all right? There you go. Okay, and then I'll just go like this. Okay, I knew you could read. There's quite a few here, so this will be like a good little fun class practice for you. I'll rewrite, let's see. I'm just going to copy and paste. It's right from the course outline. Yeah, it's, I hope you don't mind me scrolling up. kind of need to. Okay. And there we go. And then the last one. That should be it for the employee class. There's a lot there for you to try. If you don't get through all of it, you can still give yourself a pat on the back for doing it. Okay. All right. There we go. All classes end in semicolon, right? Okay, bug busters. Bug busters. What is wrong with the following declaration? In all honesty, I don't really see anything. Well, what is wrong, right? It's private, right? Kind of goes down to that question answer of making all your members private, right? Making your member data private. That's kind of what it boils down to. That's what's wrong with it. Why isn't the following class declaration very useful? Oh, that's the other thing that's wrong with it. The semicolon's missing. Little details, right? Little details. What is this they got here now? Let's see. What do they got here? Whoops. Okay. Right, looking at this, guys, right? What's wrong with this? Why isn't the following class declaration very useful? Right? What's missing? Okay, remember, it's a class. Here's another one. I'm just giving you some practice examples. I have to fix it up, though. And like this. Okay, it's got the semicolon, so that's a good start. All right, what 3 bugs in this code should the compiler find? Okay, there's 3 bugs in there. And then there's an int main part as well. I wanted to kind of get through this here quickly. There we go, int main. And then I'm just gonna go like that. Oh, goodness gracious. Sometimes when you're trying to go fast, it feels like you're going slower. All right, what do they have here? Okay, what 3 bugs in this code should the compiler find? Okay. Just looking at it, you can type the code, practice it, or first I recommend trying to figure it out just looking at it, and then type the code up. That's it. That's the end of the this section. This section was, I don't know how far back this goes here. Let's see. Understanding object-oriented programming, and then more on program flow. So how far did I get here? Let's just see. Let's see what we're getting into next. Just to give you a heads up what we're getting into next. More on program flow. Looping. Looping. Oh, this looks a little old school. Definitely looks old school. while loops. Probably just go right into that. Okay? Loops and looping, guys and gals. Johnny with Whiskey Tango Sharp Coating, I appreciate you all. We're kind of in overtime. I got to finish up. It's great to have you. Thank you for watching. Thank you for following along. You know I appreciate you, every single one of you. Beautiful, intelligent people. All of you are 100%. That is it. Whoever you are, wherever you are, I'll see you in the next video. Have a good evening, day, night, sandwich. Much love, and I'll see you in the next video. Johnny Whiskey Tango Sharp Coating saying take care for now and peace out, guys. Peace!
Baby, I don't understand this.